Okay, so for today's pre-lecture video, we're going to look at how generators produce electricity, which has to do with Faraday's law. In Faraday's law, we learned that the EMF, and this is what, remember, this is like voltage, and that voltage creates a current. And we found that this is related to the change in the magnetic flux over time, some derivative. So basically this explains how we can get an electrical current if we don't have a battery or a power supply. It's the changing magnetic flux that causes or allows an EMF, which is an electromotive force, to be created, and we can get a current without a battery. So we looked at a couple of situations how the magnetic flux can change, and the one that we're going to be concentrating on here is the electricity that can be caused or can be created by a generator. So if we have a magnet here, of course the magnet's going to create a magnetic field that's going through here, and then we have this coil, and of course the vector, area vector of that coil is perpendicular to the actual plane. And what happens in a simple generator is through some, mechanical means, like in a big power plant, it could be through a turbine that makes it turn through steam traveling through it. It's actually going to rotate, and it's going to rotate with an angular velocity of omega. And so hopefully you can see or imagine as this coil is turning around this axis, notice the axis is perpendicular to the magnetic field. You're going to have a different angle between the magnetic field and the area vector. And remember that the magnetic flux is the dot product of these two things. It's going to be A times the cosine of the angle between them. Now, if the coil is turning with an angular velocity of omega, theta, which is the angle that it's going to turn through, will be given by omega times t. So I can rewrite this as b times a times the cosine of omega t, and that's going to be the magnetic flux. So if we continue with that, when we're talking about, the magnetic flux, now we're writing as b a cosine of omega t. Again, remembering that our magnetic field looks like this, going from north to south, and our area vector is perpendicular to the plane of the coil at all times, and it's rotating with an angular speed of omega. So if we go to Faraday's law, which says the EMF is equal to the number of turns times d phi b dt, well, this is minus n, and now if I take the derivative of this expression with respect to time, I'm going to get b a, and then derivative of the cosine is minus the sine, so I get sine omega t, and my other negative sign is going to cancel that one out. And then I have to take the derivative of the angle with respect to time, and that's going to give me an omega. And so you notice that this EMF is actually not a constant value, but it actually is changing with time. And it looks like a sine function. So here's EMF, and here's t, and it's going to look like a sine function with a min and max equal to n b a omega, because that's going to be the minimum and maximum EMF, and this is minus n b a omega. And if you think about it, the current, I, is just the EMF over whatever the resistance would be, And so this is also going to have a sinusoidal function. And remember that omega talks about, or lets you, for the picture or the drawing of the sine function, omega is going to give you a sense of how quickly it oscillates. But notice that this current is oscillating. Or we could say alternating. And if you are familiar with the current that comes out of your wall, it is alternating current. It is changing as it has some alternating value to it. And here in the US, of course, it would have a particular angular frequency, omega, or F, which it happens to be 60 hertz. And so that's actually what makes current different from one location to another. You might be familiar with the fact that if you have to go to another country, sometimes you need an adapter, and that's simply because the frequency of the alternating current is different from one nation to the next, and that's why you need the adapter. So this was just a really quick explanation of how a generator works. It has to do with Faraday's law, which we're looking at right now. And of course it has a pretty practical application because it helps you understand in a very, very simple way how we can make current and power.